Guys, welcome back to another episode of Site Visit. This is really special because we are in Bavaria and I'm here with Vincent from Up Possible and James from Madeira. We're actually at their partner mill and we're going to walk through the entire process as to what it takes to take a raw log like you see behind me and bring that all the way to a finished product. And this is for the 45 white oak project. And what's really important to that project is a single sourced white oak. We're going to answer all the questions, including why didn't we source this in the United States at the end of this video. But what's really important, I really want you to understand and see what we've done here, the intentionality between sourcing a particular log and what that does for the end result. I got Nico here. Good to see you. Vincent.
Good to see you, Nick.
And James from Madeira. And we're going to walk through the entire process, starting with the logs. The log selection is actually a really important part to this whole process.
Absolutely.
We're talking about seamless wood design. We're talking about, single sourcing, all of that white oak. What does that process look like from the early stage?
Yeah, actually you choose oak as the species for this project. We mainly buy the oak from France. We went to France to make a selection of the logs, what we use for this kind of project. And here we have actually the selection. It's the highest quality we could find in a long length, in a big diameter, with a perfect grain. We will saw this into lamellas for producing the different types of material.
How are you going about making the selection? These are trees that have been already cut down and logged.
Yeah, we buy this from the state forest. It's on a log yard. It's necessary that the logs are straight, has a big diameter, and the yearing, and actually the color of the wood. So, and it's the science what needs to be good that we decide to buy this log for the project.
And then are you doing this for every project? Is that something that you're...
No, normally we produce on stock.
Yep.
Our products, but for this special project, 45 white oak, we did the extra mile for it.
I mean, there's some lengths that are up to 40 feet,
Sure.
11 meters. And to do that, you need logs like this. You see all the markings on the side? That's the length of the logs. There's the grade, there's the origin, the French origin stamp sticker there, like that one 0209.
This one, for example, means, the T means tranché, which is sliced. Like normally this quality is for sliced veneer, but
Meaning it's a higher grade.
Highest grade,
Yeah.
and we use it for as a sawn veneer for the product.
You can actually kind of find out exactly where this tree came from.
Yeah.
Exactly like where in the forest it was.
Marne-la-Vallée, south of Paris.
And the intent there...
Right back to the forest, right back to when it was harvested, its origin.
It's all PEFC certificated.
And when you're making those selections, are you traditionally trying to stay within the same region or the same...
We try to, mainly we buy the oak from France, because then we have the same color. But in this case, we bought from the same region to have exactly the same color in the raw material.
Right. Because we have a lot of parts. We have flooring, we have ceilings, we have wall paneling, we have millwork, we have stair parts, shade pockets,
box beams, all of that. A couple of these logs we're going to turn into some of the longest flooring planks that you need.
Yeah.
And then we already have other elements already in production and process. So we're getting to see it from log to finished product.
From here, you have the logs cut, and then they're moving over to being debarked, right?
Yeah.
So the debarking process, pretty straightforward process.
We just take the bark for the after sawing process, because there are stones in the bark, and so in the saw blades would be bad. So we take the bark off with this machine. So here you can see the logs, which are, let's say, naked, right?
Yeah.
And
a naked log.
Now they are ready for cutting.
Do these have to sit here in any period of time before you strip them, or?
I mean, we buy. Normally we buy the logs in the cold, like from September to March, let's say, the oak. And then we keep it there at the log yard, and then we're preparing for each week separate cutting material.
So it doesn't really have to dry much, but I noticed that there's a wax coating.
These are wet. These are like 30% moisture.
Right. All the drying happens after it's cut.
After cutting, we dry them.
From here, we're going over to
the sawmill.
The sawmill.
Yeah. So here we have actually 2 sawmills, the same type, producing here lamellas. Yeah. So
and you're saying lamella?
Yeah, it's like a thick veneer, which is used for the top layer for flooring or furniture. And our measurement is 8 millimeter thick. That's wet.
And then it was shrink down to.
So after drying, the raw material is 7 millimeter thick. Yeah. And then after calibration for the end material, it's 5.5. Yeah. So we have a lot of cuts. in this case, in this log, we have, I don't know, 120 cups. The saw blade would be 3 millimeter thick, for example. You know, doesn't make sense. So we decided to order like kind of a slow machine, but with a thinner saw blade.
So instead of one larger, faster machine, two smaller,
Yeah.
lighter gauge blades yields much more material out of the log. Everybody in this process is thinking about the utilization of the log.
So these first few passes, they're basically trying to get a square top.
Yeah. Now he cut one side, now he will cut the other side, and then we are in the same situation as
And
we
you
have
see the
here.
sapwood along the outside,
Yeah.
so we don't use any of that. We grade that out. But the sapwood is the outside of the tree where basically the sap flows.
Right.
The inside, that's the heartwood, and that's the beautiful, desirable part.
As you get to your square log, are you making a human decision as to what gets cut out of it?
I mean, we have a cutting list, so we have an order list. But if you make a stock production, yeah, then
Yeah, but this gentleman here, he knows what he's doing, and he's looking at this, thinking about it. You saw him come out with his caliper. He's looking at it, he's measuring it, and he's saying, what's the best yield to produce my cutlass?
Nico, on a log this age where you see very few branches and small branches centered to the core of the log, what does that mean in terms of the age of the log and how that was managed? If this is a 100-year-old tree, you know, how is that? How can you read the management of that tree over its history?
hard to say with this log, because there are many branches on the side as well. But if you look at the middle, so it means, let's say the log is around 100 years old. It's not the biggest, maybe 130. They cut the branches in the first, let's say, 50 years.
Yeah.
So on the outside you will not find big branches, but the inside, yes.
So that means 50 years ago, somebody who was working on the stewardship of this tree climbed up to clip the lower branches to get this grade of material. Yeah, this is thinking in 50 to 100 to 200 year time scales.
And that was really, it wasn't done for flooring.
No, it was done for ships and masts of
And the point is, if we produce long floors, then it needs to be knots or no knots.
Right.
But the problem is normally they do it like the branches cutting up to 5 meters, and then they stop cutting. So then you would have like 5 meters clear, and then knots. So it doesn't work. Yeah. So that's the point. Out of the selection, we select the wood in the forest. Yeah.
I mean, he's illustrating also some of the challenges why it's so challenging for us to get these logs in North America or really anywhere else in the world. There's not that kind of thought process that goes back, because you need centuries to do this.
So as it makes its way down, you get to this center section, and this is just cleaning off loose material before it heads into the kiln.
Yeah, that's true.
Right. So why don't we go around, and this all gets stacked up, right? So Nico, on this end, comes out through the brushes. We call it sticking, where they're taking these sticks and stacking everything up. I have to ask, because someone's going to ask, how are these made?
Company in Austria who is making it for us out of our lumber. So special species what we use for that kind of
And
sticking.
That's important because of staining and the
otherwise,
tanning.
because there's weight, and then you have in the wood if
Right.
you use the wrong one. So I cannot tell, but it's special, yeah.
Okay.
Yeah. For example, take spruce sticks, put it here on top. It's a wet lamellar. Then there's weight on top. You put it in the kiln. You will have like black strips in there, in the flooring. So nobody wants it. So it's
Which you
firewood.
don't want, right.
I mean,
Typically you see aluminum ones, but that's also expensive.
by the way, it's expensive as well. It's like it was 50 cents a stick. 50 cents one stick.
$1.75 per one of these. And you can see there's thousands and thousands
we
of
have.
these.
You need it, right?
So these come out of the brush
Yeah.
onto the table, and these guys are stacking these up. I mean, this is incredible. I mean, these have to be 20 inches.
Oh, that's more. This is going to be probably about 20.
Let's see, that's 60 centimeters.
That's 24 inches.
So after drying, minus 10%, you have like 55.
This would be a 22-inch wide plank.
Wow.
That would be the yield after you dry it, after you square it, profile it. I mean, look, and you're getting gorgeous right through the center of the tree. You're not getting the heartwood. We're not the heart yet, but you're starting to get that character.
From here, it gets sticked, palletized. My understanding is it has to sit outside for a long time before it heads into the kiln?
No, we have air drying process, yeah, let's say in the summertime, 1 to 2 weeks maximum, and then we put it in the kiln.
What's the reasoning for leaving it outside to air dry for 2 weeks?
We try to make it smooth. Like if you would put it directly in the kiln, it's wet. You get like pressure on the wood, so you get cracks, like drying cracks. We want to avoid it, so we put it in the air. It's like, yeah, smoother
It's
process.
allowing to move a little slower.
Yeah, it's a slow process.
Right.
Yeah.
And that's the duration for a sliced veneer this size, but the dry time, or sawn veneer this size, but the dry time for slabs could be years.
For slab, like for lumbers,
Yeah.
you mean? Yeah, it's years. Like if you do it correct, 1 centimeter, 1 year. So if you produce a lumber in 5
So for a
centimeter
1
thick.
inch board, 3 years.
Yeah. So that's the advantage on sawn veneer as well, right? On the lamella.
We were looking at a tabletop for a potential part of 45 White Oak yesterday, and we were talking about how long it's been air drying, and it was 8 years, and it was going to take 4 months in the kiln. To think that 8.5 years essentially to create what will be a tabletop.
So we thought like 8 years ago, we already thought about your project.
I know, it's pretty impressive.
That's the
And the
point.
guys cutting the limbs 150 years ago were thinking about flooring. And you guys keep saying lamella, and I want to make sure I answer that. It's not lamello, which you guys might be familiar with in terms of like the tenso connection. Lamella means thick veneer.
You can call it sawn veneer.
Sawn, it would be interchangeable. Sawn veneer. In our industry, we call it lamella. Yeah.
Lamella. And so this is where, different from a sliced veneer.
It's different, yeah.
Yeah. So everything here is sawn, which we talked about actually was part of a lot of our decision making was, we have sliced veneer versus sawn veneer and what that meant for our project. So what was, you really explained it better than I could. Why did we go with a sawn veneer over a slice?
Absolutely, because we wanted to match the floor and the wall panels, and we wanted to match it perfectly. So for your cabinetry and your millwork, like your kitchens, you have to go with a sawn lamella because you're treating it, you're sawing it the same way, you're prepping it. For a sliced veneer, you need a higher grade log, and then it has to basically get boiled or steamed. Just think about like when you're gonna shave, right?
Yeah.
Not that you shave that much, but you know what I mean. When you shave,
I've done it.
you need that hot water to soften up the skin.
Right.
But by heating up that log, you're basically cooking it. You're taking out you're enhancing the red colors, the tannins. It's going to look different. The structure's going to look different. But also the mechanical process of slicing versus sawing. I think sawing is
Right.
blades. Slicing is like a razor blade.
Right.
The grain is different when you do that.
You're like
You're-
almost
you're-
It's
pulling.
very subtle, but
Yeah.
you flatten the graining.
You flatten and you
of
compress the
wood,
grain,
yeah.
Right.
which means that it takes the finish and the pigment differently.
Sure.
So for the finish that we're doing and the wire brushing and the texture of that, it's going to look and feel different. It's going to read differently.
This is a very
Why we
subtle
said-
difference, but the way light hits that, and our ultimately the flooring and the sliced veneers will be brushed to raise the grain a little bit and catch light, but that difference is perceptible and it's amplified when you go to finish it and seal it. The sliced material catches light differently.
And I'm talking like the flooring is obviously sawn because it is that thick lamella, but what I'm talking about when I talk about veneers is the millwork that matches. So material we'll be building on the cabinetry, and we wanted that veneer to match. And the bees are incredible.
Yes,
The bees in Bavaria are really happy.
Yeah.
It's the time of year they're looking for sweetness.
It's the oak sweetness actually here. Yeah.
But even though those veneers will be used on millwork, which is mostly vertical throughout the building, you're still you still would perceive the difference between sawn and sliced. And so that consistency in the way you read it in light and you read it in the finishing is really important to the overall atmosphere of the project.
So where does it go from here?
Let's go to the drying chamber.
Sure. So we're walking over to the kiln.
We have two different types. One is vacuum kiln, vacuum.
Yeah.
and the other are normal heaters. So in total we have 4, and I will show you.
I noticed this yesterday. You have all this corrugated metal that you've essentially strapped to these pallets that essentially shed the rainwater. Super simple, but I think about the way we've done it, and I've seen it done in the US, like they're constantly wrapping this in plastic.
trapping
and
moisture in
Trapping
and
moisture.
let it breathe
yeah,
through each
this
season.
is giving you, I mean,
my granddad engineered it like
I hope he has a
40,
patent on it.
45 years ago. So never change a running system, right?
I think like you're shedding rainwater, right?
Yeah.
And like you're letting air flow, and I mean, you guys get a fair amount of rain too.
Yeah, we have a lot. That's a vacuum dryer, which is 50 meter long, so we can dry material up to 50 meter
Okay.
in here. The first two are regular, normal kilns with a wind and heating, right?
And
1, 2.
and how warm is it in there?
They initially 70 degrees Celsius, so that goes up to 160 degrees for one day, and that's to kill any potential bugs or insects in
Yeah.
there, and then they reduce it down
Yeah,
to the
to
correct temperature and maintain
45,
it.
50, 55 degrees.
Got it. So then they reduce it down to around 120 degrees
Yep.
Yeah.
Fahrenheit, which is not hot enough to kill any insects, but you've already done that.
Right.
And then they're stabilizing that, monitoring it remotely
Right.
until it gets to the correct 7%.
To give you an idea, for one species, oak, for example, we have at least 80 to 100 different programs.
Oh, wow.
It's a
Kilning programs.
kilning program.
And those are recipes that you've developed over generations.
Over 40 years
and
now.
for each type
So-
of kiln. Yeah.
And
You cannot decide just buy a kiln and put a wood in there and turn it on. Okay.
the most interesting part of this is the life and the length of time that a log might spend here before it exits as a product. If I was like, hey, I'm going to open a sawmill, and I get my first log, it's like that log might not leave my yard for 8 years.
At the most extreme example.
Yeah, like in the extreme, right?
Yeah.
But it's just the process to, we're talking about a premium product. Like that's what we've ultimately come down to, is that this is a product that is, very high scale, very high quality and spec, and all of the steps that go into it, like how you're going to dry that, what that's going to do, how do you get the consistency and the color down to the sticking in the material of that. It's just, that is something that's worth really calling attention to, is that this is a very long game in a lot of this.
And we're doing it at an incredibly high level here, because this is not a commodity operation.
No.
This is not, you put something in, you put a log in one side and you get a nested bundle pack of flooring out the other end.
No.
Everything is unique and special, and that's why to do a job like this, you need to be working at that level.
Yeah. So it comes out of the dryer.
Yeah.
Where do we go?
Then we have here this production hall.
So this is all stuff that came out of the kiln.
No, that's actually all stuff it's out of the kiln. They put it by hand out of the sticks. Normally this machine is doing it, but this worker here is sick since 3 weeks.
Oh, no.
And the other were in the vacation, so we react on it, so we
Sure.
did it by hand. Normally it's on the sticks here, then we place the pellet with the sticks here, and then there's a vacuum, here this vacuum
A vacuum lift.
lift, that's the
gantry.
name. Put here the one row, and then this thing put the sticks up there, right?
So it pulls all the
So
sticks out,
it's
and then
completely automatic.
wow.
So, but you need at least one guy here, right?
Sure.
So and he's sick. that's the point. So then
Like a typical company,
that's-
you're adapting to your people.
that's it. So normally, yeah. That's
You made a comment off camera about how the lengths of these veneers that you guys are producing take multiple people to move. Just to move.
normally he cuts here the end. You see it here.
Yeah.
If there is a crack, he cuts the crack.
Cut the crack off.
And
right.
then he has here 4 or 5 different lasers where he placed the width. So we cut the width after drying. You see, without sapwood.
Yeah.
And then he gives a quality stamp, like different grading, A, B, rustic.
Yep.
And then we have the pellets over there. I will show you.
And Nick, take a look at this. So this is what an example of something he's defected out, shorter lengths. But think about this: herringbone, chevrons, parquetry. This is where this goes. Because look at this. Just think about this. Yes, you have this big crack here, end
Sure.
crack. So this, you can't use this for a wide, long plank.
Right.
But if you just look at this part right here, you have perfect riffs-on, straight grained, narrow widths, right?
Yeah.
So imagine like a 3 by 24.
I mean, you could get almost a 6
You
inch
could.
board
I mean,
out
that would be
here, which
insane.
is
But
still
yeah,
considered.
you could get, and that'll
Yeah.
be great for, because you're getting short lengths. Great for patterns.
So this stuff sits here and is used.
It's for herringbone, yeah.
Yeah.
Otherwise it lands here for, like, there is a box for firewood.
Got it.
But that's we use it for, yeah, exactly.
And you say firewood, like almost everything is recycled within here. Like I noticed.
We have solar and we have heating with our own heating, so
all the wood chips and everything are used for heating the entire place.
The sawdust is pelletized. Yeah. The wood chips are used as fuel. So everything down to the bark, and the bark probably goes to the landscapers and the farmers that you saw being removed. So everything has a value.
Yeah.
Your heating during the winter is radiant floor slabs?
In the floor, yes.
You don't have any forced air.
It's in the floor.
Yeah. Which is fantastic for the stability of the wood and not drastically changing humidity.
Also for the happiness and health of the workers.
And the comfort of the
Nothing like nice warm feet. So this gets palletized.
Let's go there. At the end of this machine here is a stamp. So the stamp, make a stamp of a length, width and thickness and
so
quality.
That's all automated.
It's automatic, yeah. The guy here over there gives the information in the system and then stamps it.
Comes out heads on here.
And then here he has one guy who sort the different qualities widths in the different place.
This is a grade, right?
Yeah, that's A grade.
So that's your stamp here.
Yeah.
So for us, that's prime grade, the highest grade.
Right.
So prime grade flats on, and you're getting, what's the width on that?
It's 49 wide. So
49 wide. So you're getting something that's
for flooring 48.
Yeah. So you're getting it's a 18, 20-inch plank.
So this is actually something that we'll see in white oak. Is these 18-inch.
100%.
Yeah. And that's mixed with that prime grade, but also that more character grade because we're using the entire log.
Because you're using the entire log.
Right.
Moment. Just place it here. So here we have the A grade. For example,
this is B.
That's
B grade.
That's B. But would be selected out because there's a crack, so it would be goes into rustic select. Let's find another B.
This is a lot of labor to move this stuff around.
Yeah.
The reason that's a B is that you have some of the larger knots, but this ends up in the character grade because of the cracking.
That's a typical crack we got in the kiln. Yeah. We have around, only in oak, 200,000 square meter in stock all the time in different lengths, widths and qualities. So then it's in the stock. And if James, for example, with Madeira places an order here, then we take the stock, reviewing the stock and making a selection on this material. And then we use it.
200 square meters is 2 million square feet.
200,000 is 2 million.
Yeah, 200,000 square meters.
Is over 2 million square feet.
In oak. So we can react super quick. We sort them in different grades, different lengths and widths. So if we have an order in one grade, one width, one length, we take it, produce it. That's it.
For 45 wood oak, you're not pulling from piles of stock material. As we talked about, we're starting with the log and using the whole log for the whole project.
Because you guys understood it.
Yes.
Like, that's the point.
Well, I mean, there's so many times we're seeing specs on a floor where it's like all clear. And we talked about this yesterday where it's like, it's beautiful, but it's just not, it's not authentic.
It's not.
It's
not the real world.
Represent
Yeah,
what the tree
you're taking
is,
only
what
the best
process
of the
is.
tree, and everything else is,
Yeah, and I mean, this kind of log, this width, it's over 150, 180 years old. So, I mean, how old are we? Like, I'm the youngest, I'm 33, but I definitely cannot tell this log that the knot cannot be there, right?
Right.
Would be unfair,
and
right?
if
Because
this
he's
was
there,
like, I need
he's there over
select.
100 years. I'm 33, so I will not tell him, right?
From here, this goes over to manufacturing.
Yeah,
We go over to the production
yeah,
hall
we
now.
go into production hall.
So let's go over there. Yeah. So I was in here earlier, and I saw immediately PO white oak. This is the veneer that came from the other building.
Exactly.
And essentially is prepped for all of our long length. So
Correct. This is the long length portion of the flooring, which hasn't been pressed yet, but we basically put we've assembled basically the top lamella, right, that you're visible, and then the small pieces, the B sides, the rejected material on the underside, and we're putting it together so it maintains equilibrium and moisture and can sit like this, frankly, almost indefinitely.
Right.
But now it's going to head over to the press.
So I do want to talk about that because it's similar to when you paint something.
Yeah.
A lot of you guys have probably painted a door one side and you left it on a set of sawhorses and you go to flip it over and now it's bowed. And it's because you've kind of messed with the surface tension, and we've dealt with it in veneering, and Ken has talked about this in his veneering process at Materia, but that's what you're talking about here is you're balancing the panel. So what you do to one side,
we're keeping it together, and that this is ultimately going to be joined.
Right.
So it should be together. It should be a twin
I
right
mean, it's
now.
3 layers, right?
Yeah.
Yes.
So it's engineered 3 layers, and the back layer and the top layer we put together for let's say 48 hours to get the same moisture in it.
Yeah.
Like we dry in the kiln, we dry down to 7%.
Yep.
But I mean, you have it in the stock, then you know, it has 6 or 8.
Goes up and down, right?
So then we put it together, and then after this we put it in the press.
And that press is where you add
So
the
we have
center layer.
then we have a middle layer,
Right.
out
we'll
of
show it to you.
plywood or spruce or
Yeah.
different middle layers, and then we glue the middle layer, and then we put the back layer and the top layer together. We press it.
So this is all stocked, ready to be pressed, and this is our press over here.
That's the press. There we go. Over there.
Is this our material here?
Yeah, that's yours. That's
So
yours.
this is likely our ceiling and wall material, right?
That's the ceiling in the wall. Yeah. So it's came out of the press, and we pressed it on a spruce middle layer. So we have oak, spruce, oak.
And this is that
The
bead
back
layer
layer.
that you were
Correct,
talking
yeah.
about, and this is our finish layer. So it actually gets laid up across an entire panel.
Yeah.
And then you go back and then cut these.
And then we cut the.
Why
things
is
out.
it? I mean, I'm going to ask the question: why is it done this way? It's probably more efficient and faster.
It's more efficient because we have a machine. We glue the middle layer on both sides. You lay up the back layer in the press.
Yep.
And then you glue the middle layer, lay it, and then put the top layer on top and then press it.
Got it.
And after you cut it out.
So all of this gets done over
Yeah.
here.
So here we have a press. The press is
Looks like it's being used right now.
15 meter 50 long. It's a twin table, so we have actually one press with 2 tables, which means we have a 20 minutes pressing time. So actually after 10 minutes they're preparing the next table. So going up and the table goes that way and
That's
press
what
again.
this track is for here. Yeah.
So we can press all the time.
Yeah. So there's no downtime.
Nope.
Over there. It looks like they have their bottom
so
layer.
Here they lay down actually the back layer.
So this is just sitting on top of a vacuum table.
So here actually they laid up the back layer, right? Yeah. And now they're gluing on both sides the middle layer.
This is like a spruce pine mid layer. But if you were using a plywood mid layer, this is where you do the same
Yeah,
thing.
we're doing the same. So depending on the market,
Got it.
right? The middle layer we buy as well from Bavaria.
Yeah,
It's a spruce
that's
company.
nice.
It's nearby. Yeah, it's
It's a local core.
actually a friend of ours, so we buy there and
Keep it in the family.
super local.
The glue itself.
Yeah, I was noticing the pellets. The cutoff from this process of laminating, the adhesive you're using is a kind of adhesive that is organic and able to be burnt as part of the process for heating the mill.
Yeah, so you're not using like a highly toxic glue that if you go to burn those, you're just releasing it.
We even have no oil heater or something like that. We have nothing. We just
Solar and wood.
solar wood. That's it.
And radiant.
Yeah.
When they put the final veneer on, a lot of this glue remains exposed. How are you preventing the glue from getting on your vacuum bag?
There's a foil over there.
Yep. So that coil.
You can see it. Yeah, they're protected. And then,
So that coil gets replaced every so often.
Yeah. Actually, this machine, this press, is produced once in the world. Like in this length, it's produced once in the world for us.
This is the
Like
only
the,
one.
the
that's
company, the company engineered it with us for us. So it took us 2 years or something like that. So now it's pressing here. You can see it here.
So is this a vacuum or
That's
is
vacuum.
it? Oh, it is vacuum.
Look,
so
you can-
the hydraulics are simply to move it up and down.
Yeah.
Everything else is a vacuum.
If you ask me, vacuum is way better.
Right.
So in here you have the,
That's it.
that's it.
Simple as that. Well, let's go to where they're cutting these down.
Yeah. And there we cut out the boards.
And that's where you're taking a sheet, essentially, and turning it into individual boards.
Yeah.
Comes off there, you're cutting them into individual boards, which is here. And then it looks like there's a lot of handwork.
That's handwork, yeah.
What are they essentially doing here?
Here we have, in this case, we have knots, we have cracks. So you can see it here, what she is doing actually. She is scratching the crack, right?
Pulling all the soft wood out of the cracks and.
After that, we're filling it with a filler, with a kit.
But yesterday I saw what was really interesting is that if there's a large, ugly knot, they'll actually go and replace the whole knot.
Yeah, and then we put in a nice knot.
Yeah, find a nice knot.
A nice sound knot.
Yeah.
You can't really tell that it was.
I
it
mean,
was
there's
replaced.
no way. Yeah. So, and they're doing that with basically, again, by hand, a small hand router. going through.
There's
and
no
then-
way you can mechanize a product like this.
No.
You can't.
And this is, I mean, this is what makes this different. So from here, this gets cleaned out and it moves down to that table, and that's where you're doing the filler. You have your range of fillers, but this is being spec'd by the overall design, essentially. And this team goes through and just fills everything.
And there's two kinds of fillers that we use. There's the predetermined colors, and then there's the two-part epoxy fill, which basically creates a smooth top. The less hard, more porous one, that when we wire brush, we brush it out, so it kind of sculpts it a little bit, and that filler also takes the pigment from the finish a little bit if necessary. So for 45 white oak, for this project, we're going to be using the second option, filler that will then get brushed out to create a slightly sculpted look.
Right.
More
and that,
natural.
And we talked about from the intent, the intent is not to have this smooth, like perfect surface. It is designed to have
Understand
texture.
that it was handmade. You
Right.
see in that process.
I noticed that at this point, you're essentially squared up on either end, but you're not end matched. Where does that process come into play?
Actually, first we clean the surface, then we brush it. So
Is that all done by hand, or
no,
is
here
it?
I show you. The sander. There
So
we
this is
sanding
like a wide belt sander.
the normal sander.
Yep. Getting it. How many passes through there?
What's that?
Is it just one pass through that to get essentially?
Normally 1 to 2 pass. We try to make it in one, right?
Yeah. So it comes out and then
comes out here, and then here is a structure, like a structure.
A brusher.
Brusher.
A brusher. So
that's it.
this
So-
gives structure to the grain,
Yeah.
and you have different
Got it.
different size brushes.
something like
That's
I did.
also Italian company who did it for us. Also took us 2.5 years.
This is a
to
custom
get-
machine
custom,
for your
custom, yeah.
manufacturing
You
process.
can make super different structure on the wood.
And something like white oak has, hard and soft grain. So when you're starting to brush it, it pulls out some of that soft grain, giving it the texture that we're after.
Yeah.
So this
Yeah,
goes
that's
through,
Different.
and this is where you'd get some of that depth, James, you were talking about with the filler. Like this is where that brush would pull out some of that, so that you're not getting that
to give it a
super
more
smooth.
sculpted look. Yeah.
Right.
I think 16 or 17 different types of brushing rollers.
I'm going to call it a recipe.
Yeah.
But this would be another recipe for what you're trying to accomplish per job. Right? So you would adjust the brush heads if necessary.
Yeah, there's a program manual for this with probably
All the program.
1,000 different
Yeah.
programs.
If you're done here, we go to the profile.
So you're doing the long side, your tongue and groove, and then you're doing the short side, which is your end match. And you start with the long, so you have your blanks here, all your square, everything's been cut.
So we're making, you can see it, finished surface,
brushed,
right?
it's ready,
Brushed,
yeah.
ready. So here in this machine we get the long side tongue and groove with a bevel or not. So depending on I think we have a small bevel, a micro bevel on it.
Yep.
So we go through this machine, and then we have the Power Max where we do the short end.
And it's important that everything else is done before this. Why?
If you would have a bevel on the short end,
Yeah.
and you would brush it. You have the brusher here, so you
Ruin that bevel. So he's actually going to take a bright colored marker and give the machine a reference point to know exactly where it needs to cut. So it's going to know to cut that end before it end matches. So that's it. So you have your tongue, your groove, end match. They wait for the boards, they do them at the same time, so everything's the same. As they connect, they know they're gonna match up, and that board's done, ready for finish. And on our project, we have a custom finish. So how are we going about matching that? We've obviously made a sample, but where is that finishing process happening? One of the things that you said was your finish, you're actually gonna build a new building.
Yeah.
Because you need more space for finishing. Because right now,
50,000 feet isn't enough.
yeah, I mean, there's a lot of process going on in here. I was surprised to know that finishing was happening in the same building, mainly because I just think of dust and sawdust, but you've got 3 lines here. How does that finish get applied?
There are different sprayers and rollers, right? That's a kind of a brusher to open the
graining?
the pores, the wood again, right?
Yep.
Where you spray reactive stains, and then you have kind of brusher.
Yep.
Right?
That's like a buffing pad, basically
Yeah.
making sure that you're getting consistency.
Yeah, you put it in the wood, right? And then here that's a brusher again to open it again, and then it's done. And then, depending on the color, if you have the base color, if you have the right base color, if not, you do it again. If yes, you go on the other line, and that's the oiling line.
That's
There
the
you put-
oiling.
that's
so
there you
this
put
is
the oil.
reactive stain, and then
Yeah.
the oiling.
Yeah.
And the oiling is your top coat. It's the final.
That's a top coat, yeah.
yeah. So there's no.
So you have here pigments and all this
Right.
stuff, and on this side it's just.
So there's
to-
no
just to-
polyurethane. There's no.
No.
There's no UV curing.
No, nothing.
Or epoxy.
No.
It's all in oil.
It's natural.
Yeah.
We have nothing smoked with ammoniac or something like that. You know, we said like all the time we're producing floors for baby rooms, right? You can drink it like this kind of finished material because it's natural. That's like the pigments is out of a food industry mainly.
Got it.
So yeah.
That plays a big role into what it looks like in the final product of not being this uniform clear coat.
Yeah,
It's-
the fact that there are all natural pigments, you get that variation within the selection that you make.
That's for
as
example
opposed to
here
a
you can
synthetic.
see the reactive
Yeah.
stains really good. That's a project we did in Austria together with a partner of ours, and you know our normal.
This is not
like,
fumes. This isn't ammonia.
no, that's
fumes.
nothing.
This
That's
is
just
a reactive
pigments,
stain.
reactive stains,
Yeah, with the
pigments with
tannins.
oil, and it's like a golden color from. You see it in the pores. There's kind of a gold. Yeah, it's also for a good finish. You need professionals, and we have some guys here. They're out of the like yacht finishing industry, and
This is almost the end of the line here. You guys are making the flooring for us. You're making the ceiling material for us. You're sawing veneers for us, but you're also fabricating some of the parts. And I think you've done a mock-up for us on our shade pocket, which is also a product that will be essentially shipped flat, but pre-finished. And we had a long meeting yesterday about what that looks like, what the lengths are. Can we go up there and look at that shade pocket mock-up?
yeah, sure.
Here we are. So this is our shade pocket.
Flat pack shade pocket. Yeah.
So this is an example of, essentially you guys have fabricated this to our spec.
Yeah.
We did some shop drawings with Madeira and if possible. But you guys will fabricate this, get it all the way to assembly, pull it apart, finish it, and then ship it. And different from Lamella, these are the Lamello
Tenso.
Tensos.
Just a lamello.
Which we're familiar with in our cabinet making and mill workshop, but this essentially allows this to be assembled on site.
One of the things that was really technical about this detail is we wanted these shade pockets on the inside have valance that's the full length of rooms that are up to 30 feet. The ability to create that consistency of detail from within the span of the window, maybe this is our largest windows up to 17 feet wide, but then have that match of valance that's the full length of a room up to 30. So this mock-up was really important as part of the process.
This is essentially what goes around, you'll see around the entire room.
Yep.
And this is what all our beams tie into. On the bottom of this, we have about a 2-inch return, which would be
Yeah,
this.
that's the tight B part.
Plus, if I do it wrong, he'll just edit it out.
And you'll see after this is assembled, where the valance spans over a window, you see that thickness.
Right.
But because the face is consistent with the entire length of the room, we needed to trim that under sheetrock, under plaster walls that would be next to the windows.
Am I right in thinking?
I didn't know it was actually pronounced valence. I've always called it a valance. So.
I call it
Shame
balance.
on. Oh, you do too? Okay.
Vase,
I'm not
vase,
alone.
tomato. So this here
This is the B part.
is essentially
C.
the inside.
This is C, right?
Yep.
Yeah.
This is the inside of our shade pocket. So then we have what our shades will essentially snap, or this is where our shades hang from, and then E.
Look at this. Look at that.
And then, so in its final condition, we essentially have this. And
Which I think
this-
to really get a sense of scale of this, Nick, let's rotate it back and show the underside without that blocking. Yeah, we can hold it like this. Yeah, so that's what you'll see underneath that. And this piece spans as a
Put it down?
yeah. This piece spans the full length of the inside of the kitchen, of the great room, of all the main spaces in the building.
So this is that 2-inch perimeter beam that you see in the living room and the kitchen.
That wraps all the main spaces.
And James, actually, in our living room, in the design, you'd asked, why is there a center beam? And we were like, well, they're 31 feet long and we can't get that single piece.
Yeah, we thought we'd have to split the span.
And James was like, hold my mic.
We can do that. So this is where we're going to have full length continuous beams.
Yeah, so in the living room we have, I think it's 17 of them, but they're very long and they're full length, no seams, and they're fabricated very similar to this, where and then they tie into the valance that's around the rung.
I really like this lamello tenso system that we're using for this, because it allows us to match the grade, to pre-finish it here at the factory.
Pre-fit even.
Pre-fit it, then flat pack it, take it apart, disassemble it, flat pack it. We're going to label all your parts, so it's going to ship more easily, right? Because think about air you're shipping if you ship this.
Yeah.
It'll ship more easily, it won't get damaged or protected, and then you and your carpenters can just put it in like...
And it's snapping together.
Yeah,
right.
snapping together, it's so cool.
And not only that, but if we were to have to modify a location of a lamello, it's, this is familiar to us.
Yeah.
It's, it's not something that is...
And if you have any sharp edges like this, just hit it with a little sander, we'll give you some touch-up finish, you will never know.
That's actually a great point. We're dealing with a natural oil finish where it isn't something that, is incredibly hard to touch up.
It can be touched up by your guys in the field, and you don't have to worry about sheen match or anything like that. It's going to match because it'll be the same product.
Yeah. Everything in this project has been thought through and really kind of thought to the nth degree. But the blaring question is, why do this in Germany? From my side of it, I went to Vincent and I said I want to build 45 white oak. Him and his team designed it. I had some feedback, but it was all basically like, looks great, let's keep going, let's keep going. Early on in the process, we said Madeira needs to be part of this because of the seamless wood design, the quality of product, and frankly, it was the scale of product that you were able to share with us. I kept saying, we need it wider, we need it longer, and you came to us and said, we can do this. What ultimately leads you to a shop and a vendor in Germany versus the US?
Well, I think it goes back to the material, first of all. Obviously the shop is very important, we'll get to that, but with the material, we needed to achieve this length and this grade, this complexity, we needed the best oak in the world. And Nico and his father and family know how to buy the best oak in the world. And it pains me to say that we can't get this locally in the United States. I don't know how to do that. And believe me, we've looked, we've tried. Other industries, the way our logging ecosystem and industry is set up, it's designed for different products at different scale and different dimensions.
Some examples of that? Because there is oak available.
Oh, absolutely. It's beautiful.
But you
white
might
oak.
have the whiskey,
it goes to the wine and whiskey industry, which means shorter logs, different grades, and and that's a very valuable commodity.
There's white oak available in the US, no doubt, we know that. But the way that the industry is set up for logging it, where unless you're intercepting the guy cutting the logs, you are dealing with lengths that are shorter than what Nico and his team here can have access to.
Absolutely, and not in the same quality or grade.
Right.
So where we're able to look at these logs and know that we're going to get a beautiful product out of it. And also the level of machines is very important, and then craftspeople, the craftsmanship around that. And Nico's built a team here that can and are willing to develop these unique products.
It's not unusual that the material from the US for a project that you're trying to source the wood regionally ends up being shipped here anyways, fabricated and then returned.
Could well be.
Yeah,
absolutely. Those three elements which come together, which means that to do a project like this, we have to do it here.
Yeah.
We had a level of precision in our drawings and in our details that when it came time to rationalize this for construction and procurement and fabrication, this is something that James, we've done quite a number of projects together, something at this scale, you looked at the whole project and actually came to our team and Nick's team with solutions that we didn't realize could all be done under one
roof in one shop.
I had just assumed that this would be from multiple places, and in the end, being able to do it in one place.
Even though there may be the best intentions to take oak that's similar and try to make it match and ask mill shop A to work with mill shop B, etc., and then on-site carpenter C, and it can look pretty good, but it will never be perfect. And that's what we're saying. It will be perfect because it's the same oak cut at the same facility in the same way, finished by the same people.
It starts with the raw material. Maybe they use oak from another area region. That's it, and then you have different color in the raw material for the beginning, and then you need at the end the same finish.
Yeah,
it's difficult.
The common pushback is like white oak's white oak. And we know that that's
I would
not
say,
true. I know.
No, sir.
And even like on some of our own projects, we've when we haven't done this approach of seamless, one single source, shop, we have essentially dealt with finishes, and what we end up doing is we work with the finisher to find something that works. And one the floor might be one finish, and then the cabinetry might be different, but we're trying to match the floor. And it's not this consistency where it's, Nico, to your point, it's going all the way back to the log. That's ultimately what we're after, is the cohesiveness and the intention, right? The intention behind the design, the intention behind the material, and what it looks like, and the consistency.
We're really grateful to be able to work with you guys and take the time to put a project together this way.
Well, for a job named 45 White Oak, it would be a real shame to have done something red oak or inferior or different. It deserved it. It needed it.
Yes. Well, thank you for the tour, guys. Thanks for tuning in to another site visit. We'll see you next time.